System design. It's the process of designing the architecture, components, and interfaces for a system so that it meets the end user requirements. It is the process of defining, developing, and designing system which satisfies the specific needs and requirements of a business or organization. A systemic is required for a coherent and well-running system. Bottom-up or top-down approach is required to take into account all related variables of the system. A designer uses the modeling language to express the information and knowledge in a structure of system that is defined by a consistent set of rules and definitions. The designs can be defined as graphical or textual modeling languages. Here are the sample of graphical modeling languages. A. Unified Modeling Language or UML to describe software both structurally and behaviorally with graphical notation. Letter B. Flowchart. Flowchart is schematic or stepwise representation of an algorithm. Letter C. Business Process Modeling Notation or BPMN. Uses for process modeling language. Letter D is System Modeling Language or SysML. Uses for system engineering. Design methods. Architectural design to describe the views, models, behavior, and structure of the system. Logical design to represent the data flow, inputs, and outputs of the system. Example, ER diagram or entity relationship diagram. Number 3, physical design, defined as how user information to be systemic and how the system represents information back to the user, or how the data is modeled and stored within the system, and how the data moves through the system, and how data is validated, secured, or transformed as it flows through and out of the system. Logical and physical design. Logical design or logical database design is a low-level description of entities that are defined and how they are related to each other, and what kind of data is to be stored. This model determines if all the requirements of the business have been gathered. Logical database design involves creating a data model that shows an organization information. If you think you might be interested in a career working with logical database design, read on to learn more about the education and career points. The physical design or physical database design deals with how the data will be stored in a database using with suitable DBMS, and this design is generally created by database administration and developers. The physical design of our database is optimizing performance while ensuring data integrity by avoiding unnecessary data redundancies. The task of building the physical design is a job that truly never ends. As a result, you need to continually monitor the performance and data integrity as time passes. Many factors necessitate periodic refinements to the physical design. The difference between the logical and physical design. Logical database design or logical design describes the data without regard to how they will be physically implemented into the database, and defines the data elements and their relationship, and simpler than the physical database design. While the physical database design represent how the actual database is built and represent how the actual database is and complex than the logical database design.
Prototype design. It is a powerful process detailing how designers do everything required to test, iterate, and develop prototypes, beginning with user flows and ending in functional wireframes. And also, it is a sample of a product designed to test an initial assumption or a concept about that product. Prototypes are used in a variety of different industries, including but not limited to design, electronics, software engineering, semantics, and many other fields. Types of prototypes: proof of principle prototypes, working prototypes, visual prototypes, form study prototypes, user experience prototypes, functional prototypes, and paper prototypes. Proof of principle prototype serves to verify some important concept of the design but doesn't represent an expected final product. Working prototype represents practically all of the functional of the end product. Visual prototype represents the size and appearance but not the functionality of the intended design. Form study prototype is a type of a visual prototype where special attention is given to geometric feature of a design rather than color, texture, and other aspects. User experience prototype represents exactly enough details of the product to make it easily recognizable as almost the final version. Functional prototype captures both function and appearance of the intended design, although the final design might still be different in scale or technique. Paper prototype is a hand-drawn or printed representation of a user interface or a software product. What is the difference between a wireframe and a prototype? A wireframe is a graphical representation of a website that guides its content and concept of the pages and help the designers and clients see what a website is being built. While prototypes are usually dynamic and interactive, some even look like the final product. And also, a wireframe is a small fidelity model of a website that consists of a black and white layout with lines and boxes and other design elements that shape the structure of a website and express the main visual of a user interface, while the prototype is offer a complete or almost complete user experience for testing and evaluation process. Reasons to prototype, for example, is if you are presenting early prototype to investors, stakeholders, and executives, help you better communicate about wants and needs of all involved parties. It's easier to sell your own ideas and attract more investors.
System design is the process of defining software and hardware architecture, components, modules, interfaces, and data to allow a system to meet a set of well-specified operational requirements. The industry of computer system design is the one that writes the software that runs computers, designs the integration of software and hardware, and operates data processing facilities. Computerized system design develops enhanced systems for emerging workloads, especially in the area of cognitive computing. Design principles are the guidelines and considerations that designers apply with discretion. It is the fundamental pieces of advice for creating user-friendly and pleasurable designs. But why do we need design principles? The design principles makes our product or design values high, makes our design more elegant, and when the principles are applied, it ensures consistency in decision-making across designers and teams. There are 12 basic principles of design. Number 1 is contrast. It is the opposite arrangement in elements and effects. For example, black font and white background, or in large shadings and small body in text. There's a contrast between them. Balance. It is the distribution of visual weight objects, colors, textures, and space. Balance creates cohesiveness, completion, and satisfaction in our design. Number 3, emphasis. In design, the part of emphasis is to catch the viewer's attention. We see it used in most fields of design. For example, using a dark colored element within a brightly colored page. Number 4, proportion. It is the relationship between one part to another part of design or to the whole design. It signals what's important or not important in a design. For example, If one element increases in size, the remaining element should also increase at the same rate to remain proportionate. Number 5, hierarchy, gives us order to make sense of design easily. For example, where do we want the eye to look first, second, third, and so on? Mostly we see first is the headings and menus. Then second is the introductions and body. Number 6, repetition. It's like using or repeating element many times in a design. It is a great way to add textures and unity to the design. Example, repeating a logo of business in every page in the same place. Number 7, greeting. It is a visual tempo or beat. It helps in how the viewers perceive this space in terms of punctuality and appearance. Number 8, pattern. It is just like repetition, but pattern is the repetition of more than one design element, while repetition focuses on a single element being repeated. Number 9, white space. It is an empty space around the content and factual elements of the page. The role of this is to let your design breathe by reducing the amount of text and functional elements that users see at once. Number 10, movement. It refers to the path that the viewer's eye takes through a composition. Movement in a composition creates interest and dynamism that keeps the viewer engaged. Number 11, variety. It is about creating visual interest that will keep viewers engaged with your design. Holding their attention and guiding them through the composition will create a powerful user experience. Number 12, unity. It is the harmony produced by all the elements in a design piece. It guides the designer on how to best leverage all the other principles to present a composition that is both harmonious and whole.
The data lifecycle. The data lifecycle is a series of steps that a specific piece of data takes from the time it is created or captured until it's eventually archived and or deleted at the end of useful life. Since it is also known as the information lifecycle, all of the information is included. There are 8 types of data cycle. The first one is generation. Regardless of your awareness, particularly in our increasingly connected society, this information is produced in a part by your company, in part by your clients, and in part third parties that you may or may not be aware of every transaction, including sales, purchase, hires, and communication interaction generated data. The second one is collection. Every day, a lot of data is produced, yet not all of it's gathered or used. Your data team should decide what information needs to be collected, and the most effective way to accomplish as well is the information are superfluous or unrelated to the project at hand. The third one is processing. Processing, once a data has been collected, it must be processed. Data processing can refer to various activities. The fourth one is data wrangling. It involves cleaning up and transforming a data collection from its unprocessed state into something more unstable and accessible. This is sometimes referred as a data cleaning up, data cleansing, or data smuggling. The fifth one is data compression, in which data is transformed into a format that can be more efficiently stored. The next is data encryption, in which data is translated into another form of code to protect it from privacy concern. The next is storage. Data must be preserved for the later once it is been gathered and processed. The most popular way to accomplish this is via building database or datasets. These datasets may keep of server in the cloud or on a hard drive, CD, cassettes, or floppy disk. Data management. The data organization, storage, or retrieval as needed during the life of the data project or all parts of data management. Also, known as database management. Even though it's called a step in this context, the process continues all the way through a project. The next one is data analysis. Processes used to try to extract valuable information from unproposed data are referred to as data analysis. To carry out those investigation, analysis, and data scientists employ various tool techniques, and the more popular techniques include data mining, machine learning, artificial intelligence, statistically modeling, and algorithms. The next is visualization. It is the process of producing graphical representation of your data. Usually, using one or more visualization tools. When you visualize data, it's simpler to simply explain your findings to more people both inside and outside of your company. The format your visualization takes relies on the data you're using, the narrative you want to tell. System design task list. System design. The process of creating a system, components including its architecture, modules, and components, as well as its many interface and the data it processes. It is known as system design. A task list is a project management tool that helps professionals keep track of their team tasks. Task management system or TMS across different domains and its several variations. The first one is priority. Tasks have different importance, so we need to treat each task differently. The second one is shared. There is a task pool and the workers pick up them based on their priority. The third one, the variety. Each task requires differently skills or steps to complete. Fourth, time-bounded. Each task has been expected completion time and we need to make sure to complete maximum tasks on the time. If the tasks are approaching their deadline, then task priority will be increased automatically. The next one is workers. Can be a humans or machine and they complete the task according to steps and priority. We need to maintain their status as they may be unable all the time. The next is comments. We can add comments to tasks as we work of them.